A deep dive into scikit-learn's HistGradient Boosting Classifier. The HistGradient Boosting Classifier in scikit-learn is a powerful and versatile algorithm for classification problems. It combines the strengths of gradient boosting, histogram-based binning, and light GBM-inspired techniques to achieve high accuracy and efficiency, especially on large datasets. Let's break it down. 1. Gradient boosting. Core concept: gradient boosting is an ensemble method that sequentially builds a collection of weak learners, usually decision trees, to make predictions. Each tree attempts to correct the errors made by the previous trees, focusing on the misclassified instances. How it works. A first simple tree is built on the entire dataset. The residuals errors between the predicted and actual values are calculated. A second tree is trained to predict the residuals, effectively focusing on the misclassified samples. This process continues, creating a series of trees that collectively learn the underlying patterns in the data. Advantages: high accuracy, often surpassing other algorithms, robust to outliers and noisy data, can handle a mix of continuous and categorical features. Disadvantages: can be slow to train, especially with large datasets, requires careful parameter tuning for optimal performance. 2. Histogram-based binning. Core concept: instead of directly using the raw values of features, HistGradient Boosting Classifier first divides them into bins intervals. This discretization simplifies the decision-making process within the trees and speeds up the training process. How it works. For each feature, the algorithm identifies optimal bin edges based on the distribution of values in the training data. Instead of comparing exact values, the trees compare bin indices, making the splitting process more efficient. Advantages: faster training times, especially on large datasets, less susceptible to overfitting, as binning reduces the number of potential splits. Disadvantages: may lose some information in the binning process, requires careful tuning of the number of bins to avoid losing too much information. 3. Light GBM-inspired techniques. Core concept: the HistGradient Boosting Classifier borrows some innovative techniques from the popular light GBM algorithm, which is known for its high speed and accuracy. Key techniques: exclusive feature bundling. EFB groups features with low correlation to reduce the number of splitting points considered, further speeding up training. Categorical feature splitting handles categorical features efficiently, allowing for more accurate splits. Gradient-based one-sided splitting, a faster way to find optimal split points for continuous features. Advantages: increased speed and accuracy compared to traditional gradient boosting algorithms, improved handling of categorical features. 4. Key parameters. Learning rate controls the step size taken at each iteration, influencing the overall model complexity and learning rate. Lower values lead to slower but more robust learning. Maxiter: the maximum number of trees to be built, limiting the model complexity. Max depth: the maximum depth of individual trees, controlling their complexity. Deeper trees can capture more intricate patterns but are more prone to overfitting. L2 regularization. Strength of L2 regularization, which penalizes large weights in the trees, reducing overfitting. Min samples leaf: the minimum number of samples required in a leaf node, preventing the creation of very small and unstable trees. Scoring: the metric used for evaluating the performance of the model during training. Early stopping: a mechanism to stop training early if the performance on a validation set plateaus or decreases, preventing overfitting. 5. Applications. Credit risk assessment: predicting loan defaults, evaluating borrower creditworthiness, fraud detection, identifying fraudulent transactions in finance, e-commerce, etc. Medical diagnosis, classifying diseases based on patient symptoms and test results. Image classification, categorizing images into different classes, e.g., animals, objects. Sentiment analysis, determining the emotional tone of text data. 6. Advantages of HistGradient Boosting Classifier. High accuracy and efficiency combines the strengths of gradient boosting, histogram-based binning, and light GBM-inspired techniques for excellent performance. Robustness, tolerates noisy and diverse datasets, making it practical for real-world applications. Scalability, efficiently handles large datasets, making it suitable for big data analysis. Versatility, can be applied to a wide range of classification problems. Ease of use, provides a user-friendly interface with sensible default parameters. 7. Disadvantages. Complexity, requires careful parameter tuning to achieve optimal performance. Interpretability, the decision process of a boosted ensemble can be difficult to interpret. In summary, scikit-learn's HistGradient Boosting Classifier is a powerful and highly optimized algorithm for classification problems. It offers high accuracy, efficiency, and robustness, making it an excellent choice for a wide range of applications.